All right, in this video I'm going to show you how to set up Kirchhoffs equations and actually solve for what the currents are. And then in the final video I'll show you how to answer all these little questions here. Okay, but we'll answer these questions for this. Okay, the page just gets kind of full, right? So again, what we're going to do is we're going to guess. The first step is, okay, guess the direction of the currents. Okay, so set up your currents. Okay, that says currents, okay? So I'm going to guess that the current here, I'm going to call this guy I3. I tend to go like, I1, I2, I3. I'm going to call this guy I3, okay? I'm going to guess that this battery is also pumping current in the direction it wants to pump it. This turns out, by the way, to be wrong, but that's okay. I2. And then I'm going to guess that all that current that flows into this junction here, right, flows back to the other side of these batteries this way. Okay. So it helps, I don't know, it helps me to just kind of be like all clear about this, right? Okay. So set up the currents, right? The next thing is set up your junction equation. And how many junction equations should you set up? I always like, whoa, you need to set up as many junction equations as there are unique junctions. Now, these junctions aren't unique, okay? For example, this one's going to yield I1 equals I2 plus I3, and this one's going to equal I2 plus I3 equals I1, and those aren't unique, so you can't; those don't count as two equations, right? All of our examples, though, will be just like this. So I'm going to look at that junction right there, okay, and I'm going to say I2 plus I3, right? Those are the currents flowing into that junction, equal I1, right? I2 plus I3 equals I1. I think we can all agree with that, okay? And then over here, I'm going to write this down. As a matrix equation. So I'm going to say negative I1 plus I2 plus I3 is 0. Right, so we're going to set up all our equations right here, and then of course we need to do some matrix stuff to solve it. Okay. Now I'm going to do a little loop here. Let's. I'm going to do a. How about a green loop? Okay. So I'm going to start right here, and I'm going to traverse this circuit kind of like this. I'm going to go whoosh, that way through this whole loop, starting and ending right there. Okay. So let's set that guy up here. Are we ready for this? Okay, so let's see. I'm going to go minus 6I1. Okay, now I'm going here. I'm going through this. So I did that, right? I'm going to go through this guy. I'm going to say minus 8I2, because I'm in I2 now, right? Do you notice that? Plus 5. All right, minus 7I2. All right, here I'm not. So I've done this. I did this, right? The next circuit element I encounter is that resistor. So I'm going to say minus 5I1, 0, right? Okay. And I think I've got that right. So let's just double check, right? So minus 6I1 downstream through the I1, 6 ohm, right? Downstream through the 8, but it's I2. Up through the battery, right? Downstream through the 7 ohm, right? Downstream through the 5 ohm. Notice it's I2 here, but it's I1 over there, right? Okay. So let's write this equation a little better. Let's consolidate things. We actually have minus 11 I1s, right? I'm combining that term and that term, right? We actually have minus 15 I2s. We have 0 I3s. And then that equals negative 5. Because I put the 5 over there, right? Remember, when you do this, you've got to make it look like a matrix equation. So put all the constants over here. Put the I1 as the first term, I2 as the second term, I3, right? So our equation now looks like minus 11 I1 minus 15 I2 plus 0 I3 equals negative 5. All right, so now let's use a different color. It helps use a different color, I feel like. Okay, let's do red. So now I'm going to do this loop here. I'm going to go whoosh, like that with this loop, okay? So I'm going to just traverse this. Now the rule for your loops are you've got to visit every circuit element just once. That's your only rule, okay? We need to make two unique equations. I can't like start here and do this one, you know, clockwise. It won't be a unique equation. But if I visit these circuit elements, it's for sure going to be a unique equation, right? Okay, so let's go in here. So let's see. We want to encounter this. We're going downstream through the 4, so 4i3. Going downstream, right? So it's negative minus 3i3. You could just, by the way, say negative 7i3, right? Okay. And then we're going to go the proper way through the battery. We're going to go up. We're going to go from low pressure to high pressure, right? So plus 23. Okay, the next thing we encounter, right? So we're just encountering all these things, right? We're going downstream, so minus 9i3. By the way, you can just say, you know, eventually you'll go, oh, gee, there's 16 i3s, right? Okay, and now we're to here. Now we're going upstream, so we have to say plus 7 i2, right? And it's positive because we're going upstream through it. Then we're going to go down 5, right? Because we're going here. That's our next thing that we encounter. And we're going the wrong way through the battery, right? Okay, so let's see. So up 7 i2, down 5. Then we're going to go up 8 i2. Right? And now we're home. So let's just double check this. Okay. We've got 4 and 3. And so 4 and 3. We got 23. We went up 23, right? Okay, down 9. Then we go up 7, down 5, up 8. Yeah, okay. So up 7, down 5, up 8. Boom, we're back, right? Obviously, we need to like fix this thing, right? So let's see. We have 0 I1s, right? How much I2 do we have? We've got 7 and 8 I2, so plus 15 I2, is that right? So plus 15 I2. How much I3 do we have? Do we have minus 16 I3? Yeah, we do. Let's see. We got 3, 7, 3, 3, 4, 9, and that's it, right? That's minus 16 I3. And then let's see, we put this on this side and we get that equals negative 23 plus 5. Is that negative 18? I want to say it is. Okay. So our equation is 0 I1. We didn't encounter I1, right? But we're saying 0, so we have a placeholder for our matrix. Okay, plus 15 I2 minus 16 I3 equals negative 18. Yeah? Holy cow, look at all the writing we've got there. Okay? And those, I think these are correct, right? So I by the way, I double check because I always make little mistakes. One tiny little mistake, and you're not a little bit off. It's a lot off. Okay? So now what we need to do is we need to go into matrix land, right? So let's go back to blue pen land. I feel like the blue pen is calming. Okay? So what we're going to do is we're going to represent this equation with these matrices, right? We're going to say negative 1, 1, 1, negative 11, negative 15, 0, 0, positive 15, negative 16, right? Times I1, I2, I3 equals, and I'll call this matrix A, right? And then I'll call this matrix B. And then the answer matrix is 0, negative 5, negative 18. Call that B, right? And then what we have to do is we have to do A inverse times B, okay? So the answer matrix, I1, I2, I3, or the matrix with the, I don't know what to call it, okay, is equal to A inverse times B, right? And I think I showed you last year how to do that. I can show you in class if you forgot. And I think there's even a video here where you see me doing it on the calculator. Okay, I think though I use the old-fashioned matrix thing. I'm very fetched with it. Let's see, it's alpha, there it is. Alpha F3. Is it F3? Yeah, it's the third one over, the one that says zoom, okay? On your TI-84s, hit alpha F3, go in there and select a 3x3 matrix and be amazed. So go over the 3, hit OK, hit enter. And now I see a matrix on my screen with 0, 0, 0. I'm going to type in -1, right arrow, 1, 1, 0, -15, -11. I'm just going through, I'm typing in these elements here, right? And then the one below that is 0, the one, next one is 15, the next one is -16. All right, let's see, do I have it right? -1, 1, 1, -11, 15, 0, right? 0, 15, -16, right? And then I'm going to invert that matrix. So hit the x to the -1 button. It's right below math. Fourth button down on the left side, right? And then you go alpha F3 again. And you want 3 rows, but you only want 1 column. I always get it wrong too. Okay, 0, -5, and -18. Okay, and you hit enter. Oh my God, I'm so nervous. Padumba. Okay, now when I do this, I get this matrix. I get 0.73149. I get -0.203098. I get 0.93459. Now, this negative sign means that I2 is negative. Okay, it's like, uh-oh. Well, don't let it get you down. All that means is that the current, we guessed that the current flowed the correct way through the battery. The current doesn't flow that way. The current actually flows this way. This big bully 23-volt battery is actually pushing current the wrong way through that. How do you think that little battery feels? Okay, it's pushing the current that way. We guessed wrong, okay? So I2 is actually down the page. So if we answer this through the 5 ohm resistor, right, we guessed down and it was positive, so it is down. So we'd say 0.73149 down. You have to say which way it is, right? Through the 7 ohm resistor, it's also down. Now we guessed up, but we got a negative answer, so that means it's down. I'm sorry, this is very confusing. So I get 0.203098, right? And that is also down. And the only one that's up, is the 3 ohm resistor, right? So the 3 ohm one is 0.93459, and that's up, okay? And you can, yeah. And you can, by the way, you can show that this current here splits into those two currents. You can add those two up and you should get this, okay? In the next video, I'll show you how to get the voltages and all of that stuff, okay? But I think I'll put that on another video because my pen is getting slower and slower as I have more writing on the screen.